This lesson is on conversions. Our objectives for this lesson is to identify a whole number, improper fraction, proper fraction, and mixed number. So we're going to be going over the vocabulary of these. Convert a mixed number to an improper fraction, and to convert an improper fraction back into a mixed number. So let's go over some of the fraction vocabulary. First, let's make sure we understand what a fraction is and the parts of a fraction. When you see a fraction, the top number is called the numerator. It represents a portion of some whole, kind of like a slice of a pie. The bottom number, or denominator, represents how many slices make up a whole. So look at our example here. You have this whole pie, and you notice that one slice of the pie is colored in. So if we wanted to write a fraction to represent that one slice, you would write 1 over 4. 1 being the slice that, let's say, you ate out of the 4 slices that were in one whole pie. To help you remember the difference between numerator and denominator, just remember denominator down. They both start with the letter D, so it's the one that's below or down. A whole number is a number that, a natural number, like for example, that you count 1, 2, 3, or 4. These are the types of numbers you've been used to working with. So a key concept with fractions is if the numerator and the denominator are ever exactly the same, it is always equal to 1. Because if you ate 4 slices out of a pie that's sliced into fourths, then you've eaten one whole pie. There are different types of fractions. A proper fraction is one in which the numerator is smaller than the denominator. Look at our example of 1/4. You would read it as 1/4, just as I said there. So the top number, or numerator, its value is smaller than the denominator. To help you remember this, if you were to stay petite and small, and to stay proper, you would always eat less than one whole pie. An improper fraction is one where the number on top, or your numerator, is larger than the number on bottom. So here's an example in a picture. Do you see in the picture how we have 9 slices colored in? But each pie is divided into 4 slices. That's how it's cut. So there are 9/4. Whoever was eating all of this pie would obviously become top-heavy if they ate that much. So that's how you can remember an improper fraction. It's a fraction where the number on top is bigger or top-heavy. Another way to write 9/4 is as a mixed number. You probably saw this and were like, wait a minute, I see 2 whole pies there. When you mix a whole number with a fraction to describe an amount, like what you see here, 2 and 1/4, it's just another way of writing an improper fraction, but you write it as a mixed number, a whole number and a fraction together. So in these lessons, you're going to learn how you can convert fractions, improper fractions, into mixed numbers, and mixed numbers back to improper fractions. Let's first practice and make sure you can identify the different types of fractions. Alright, look at number 1. You have 5/6. What type of fraction is that? Notice that the number on top is smaller than the number on bottom. So that is a proper fraction. Number 2, you have 9 3/7. You see a whole number with a fraction right beside it. So this is a mixed fraction. In practice 3, you have 12/5. The number on top is bigger than the number on bottom. It is top-heavy. So that is called an improper fraction. And the last one, 13/13. Because the same number on top is the same on bottom, this is what we call a whole fraction. Because this fraction can be turned into a whole number, in this case 1. As I showed you in the vocabulary above, that mixed numbers could be referred to as an original improper fraction. You will learn in subsequent lessons that you will have to convert mixed numbers into improper fractions in order to perform most operations like addition, subtraction, multiplication, division. But in standardized tests, such as the Algebra ECA, you may be asked to put a final answer into a grid, like the one you see here. It is important to remember you never put a mixed number into a grid. When the computer grades questions that look like this, they look for blank columns. That's when the computer knows that you're done inputting your answer. So therefore, if you were to put in a mixed number, for example, 6 1/2, notice you see this blank column here. And if you put it together, it would look like 61/2. So in either case, the computer is going to grade this wrong. In fact, the computer would just stop at that blank column and consider that a 6. So there's some rules when working with the grids. First of all, just as I did here, you always write your answers from left to right. The computer expects that you're going to have some blank columns. You do not fill in any blank columns if the answer doesn't go beyond, typical answers will not take up every column of your answer grid. Never skip columns. Don't fill in any columns at the end of answers, so there's no little blank circles. And answers can never be mixed numbers. So this is why we need to learn how to change a mixed number into an improper fraction. To convert a mixed number into an improper fraction, you'll use 3 easy steps. And remember the word mixed fraction? Think of like a mixing bowl. You're always going to mix or stir clockwise to solve these. So you start at the bottom, like you see here with my little mixing spoon, and you're going to multiply your denominator times the whole number, and then add your numerator. That answer you will write over the original denominator. So I have that example there of 3 2/9. I multiply 3 times 9, and that's how, when you get 3 times 9 is 27, and add 2, that's how I got the 29. And then I wrote it over the denominator I started with, the 9. So let's try it with a few of these, and then you try too. Start at the bottom. 10 times 9 is 90, plus the 6 is 96. You write that as your numerator, and write it over the denominator, 10. So 9 6/10 is the same thing as 96/10. Let's try another one. 9 times 2 is 18, plus 2 is 20. And then you just go back to the beginning. What number did you start with? The number 9, and that's the number that goes on bottom. Go ahead and try problems number 3 and 4 on your own. Push pause, and when you're ready, let's check your answers. Okay, you ready to go? On number 3, you started with the 8, and you should have multiplied by 10. 8 times 10 is 80. And then added your 4, so 84 over the original 8. So you just go around clockwise, starting at the bottom. Look at number 4. 7 times 4 is 28, plus 3, so 28, 29, 30, 31, all over the 7. How'd you do? In almost every operation that involves fractions, you cannot work the problem with mixed numbers. You have to change mixed numbers into improper fractions. Now there are a couple operations where there's methods that you do not have to do this, but we do subscribe, at least at the Excel Center, to changing all your mixed numbers to improper fractions. It does seem to work best for our students. All whole numbers can also be written as an improper fraction. In order to change a whole number, like in our example 24, into an improper fraction, you simply put a 1 under it. So if you ever have a whole number and they ask you to write it in fraction form, just simply put a 1 under it. Now I don't think you need to practice that, but I do need for you to know, because I've seen some students do this before, If you have a mixed number, you would not put a 1 underneath the whole number part of the mixed number. You see my example, 2 3/4. How the student just put a 1 underneath the 2, so it looked like they have two fractions, 2/1 and 3/4. Well, what in the world are we going to do with that? You don't. Remember, if you see a mixed number, that's where you mix it up. Mixed number, mix it up. Oops, I meant to get my pen out. If you see a mixed number, you mix it up. So it should have been 2 times 4 plus the 3, so 8, 9, 10, 11, over the original denominator of 4. So you write it as 11/4, not 2/1 and 3/4. If your fraction is already as an improper fraction and you're not working with a problem that involves putting your answer into a grid, you're more likely going to have to change your final answer, if it's an improper fraction, to a mixed number. So let's go over the steps on how to do this. This will be done in 3 steps. The first step is you have to divide the numerator, remember that top number, by the denominator. Now when you divide, you're going to get a remainder, or you usually will get a remainder. There is a time where you won't. And what you will do with that remainder is write it on the top, or make it the new numerator. So I'm going to go over this example here. Here we have our numerator of 14. Notice it's put in the box of the division box. So there's a way to remember this. I call it the magic spell of changing an improper fraction to a mixed number. The magic spell is top in the box, cat in the hat. It's just a simple, silly rhyme to help you remember the steps of converting an improper fraction to a mixed number. So what I mean by top in the box means you take that top number, your numerator, and put it inside your division box. Like what you see here, the 14 is inside our division box. And then you have to divide. Well, 4 goes into 14 3 times without going over. It doesn't go in exactly. Comes close at the number 12. So 3 times 4 is 12, and you see I wrote it down there below, and then subtracted to find out my remainder. Now, in early mathematics, you might have written your answer as 3R2 for 3 remainder 2. What you will do with a mixed number is instead of writing it as a remainder, you take that remainder and write it as a fraction. So the remainder becomes your new numerator, or the top, or the hat of your fraction. That's where I get the cat in the hat. Just a simple little rhyme to remember what to do with that numerator. It becomes the hat of the fraction. Oops, sorry, I was supposed to get the eraser. So you see you have the mixed number 3 2/4. But wait, you still have one more step. You won't always have to do this when you convert to a mixed number, and that is you need to reduce the resulting, that's supposed to say proper fraction there, and it will be fixed on your worksheet. Sorry, my video will have the word improper. It's supposed to be the proper fraction. So when you do your division, you have a proper fraction here of 2/4. The number on top is smaller than the number on bottom, but that doesn't mean it's in its simplest form. Remember, when you have a fraction, if there's any number that you can divide both the numerator and the denominator by, or basically the greatest common factor, then you must do that. Well, the greatest common factor the factors of 2 are 1 and 2. The factors of 4 are 1 and 4, and 2 and 2. That means the greatest common factor is 2, and it will reduce to 1/2. Therefore, our answer can be written as 3 1/2. We had to reduce that fractional part. Alright, this is going to take some practice, I know. Let's try it with the problems below. Remember that you can only change an improper fraction to a mixed number. Proper fractions can't be greater than a whole, so it will never be a mixed number. So in one of these fractions, there is a proper fraction here, and you need to be able to identify it when you get to it. So our directions are to convert all the fractions into mixed numbers. If the fraction is a proper fraction, therefore it can't be converted, write the word proper, and reduce all answers to lowest terms. So let's take a look at the first one. 33/24. Is that an improper fraction? Yes, because the top number's bigger. Alright, if the top's bigger, then you put the top in the box. By the way, you probably won't have enough room on your paper to do all these. If you need to do them on a separate sheet of paper, I completely understand. I'm probably going to do them side by side here. I don't have room to work as well. How many times does 24 go into 33 without going over? 1 time. So then you have to multiply 1 times 24 and then subtract to figure out your remainder. I can't subtract 4 from 3, so I have to borrow. 13 take away 4 is 9. 2 over 2 to take away 2 is 0, so I just don't write it. So I have this remainder of 9. There's nothing else to bring down. So that becomes the hat of my fraction, 9 over 24. Now I know 9 over 24 can still be reduced. My whole number, remember, does not go away when I'm reducing my fraction. So make sure you write that down. I see many students just write down the fraction after they reduce it, and they forget about that whole number there. I'm going to do 9 over 24 here off to the side. So my factors of 9 are 1 and 9 and 3 and 3. There's no numbers between 3 and 3, so I know I'm done there. 1 and 24, 2 and 12, 3 and 8, 4 and 6, and there's no numbers between 4 and 6. So my greatest common factor, if I look, it looks like the greatest common factor is 3. That means the fraction can reduce to 3 over 8. 3/8. So 1 and 3/8 is your final answer. I'm going to have to do some erasing so that I can do the next problem, but I'll write in the 1 and 3/8 for you. Alright, the next one, 22 over 14. Is it improper? That is definitely a question you need to ask yourself before you start trying to convert anything to a mixed number, because proper fractions cannot change to a mixed number. It is top-heavy, so I need to put the top in the box. Divide by 14. 14 can go into 22 just 1 time. So then I have to subtract. Looks like I need to borrow again. 12 take away 4 is 8. So I did the top in the box, and then I made the cat in the hat. I made my remainder be the hat of the fraction. 1 and 8/14. I'm going to check to make sure that 8 over 14 can't reduce. So I'm going to find all the factors of 8 and all the factors of 14. Look for any greatest common factors. Looks like 2. So the fraction reduces to 4/7. So the other way to write 1 and 8/14 is 1, yeah, don't forget that whole number, and 4/7. Do you hear me when I'm saying the fraction out loud, 1 and 4/7? When have you, when you were describing numbers or reading them aloud, have you used the word and before? Remember when you were learning decimals, they said only use the word and when you're talking about what comes after the decimal point? A fraction is just another way of writing a decimal. It's something that's less than 1. So you would say 1 and 4/7. Alright, I'm going to have to erase again to give myself some room for the next problem. So the next fraction you see there is 4/36. So what type of fraction is 4/36? It is proper. I'm going to go ahead and write the word proper, because remember, you cannot change proper fractions into mixed numbers. Now, proper fractions can, though, be reduced. So let's go ahead and reduce that fraction, or check to see if it can reduce. Find all our factors of 4 and all our factors of 36 and see if it can reduce. 1 times 4 is 4. 2 times 2 is 4. And there's no numbers between 2's. So those are all the factors of 4. Let's write the factors of 36. 1 times 36 is 36. When you're finding your factors, it's actually division. It's like 36 divided by 1 is 36. 36 divided by 2 is 18. 36 divided by 3 is 12. 36 divided by 4 is 9. You can't divide 36 by 5 because it doesn't end in 5 or 0, but 36 divided by 6 is 6. There's no numbers in between 6, so those are all the factors of 36. There's quite a bit. But what's the greatest common factor of both numbers? 4. So that means our fraction 4 over 36 can reduce to 1 over 9. Isn't that nice how if you write them as factor pairs, you can see what they reduce to? It's just the number that's right beside it, or its factor pair. Let me erase again so that we can answer the last question. While I'm erasing, why don't you go ahead and try to do it on your own and then check your answer with me. So go ahead and push pause and give it a try, and then push play when you're ready to check. Okay, let's see how you did. 68 over 28, well, it's top-heavy, or it's improper is the actual word we need to use. It's an improper fraction, so we put the top in the box. You divide by 28. Well, how many times can 28 go into 68? If you're ever having trouble with trying to decide how many times it could go into without going over, then use a little estimation. 28 is pretty close to 30, and 68, well, you could say 70 or 60, put in there. So it looks like 30 can go into 60 about 2 times, maybe. So let's just try it, and if it's too big, then we'll just drop it down a little. 2 times 28, so 2 times 8 is 16, carry my 1. 2 times 2 is 4, plus 1 is 5, is 56. If you needed to do the problem off to the side, I understand. Some people have to do that. 28 times 2, times 2, to figure out what it multiplies. So 2 times 8 is 16, carry a 1. 2 times 2 is 4, plus the 1 is 5, is 56. So that's how I got the 56. And then you have to subtract. Now the way you know if your number that you divided into is too big or too small is by your remainder. That remainder, whatever answer you get here, must be smaller than the number you're dividing by. If it's too big, then this number is too small. So let's try. 8 minus 6 is 2. 6 minus 5 is 1 is 12. So what's our remainder? 12. So is that too big enough then? Yeah, because 12 is smaller than 28. Your remainder must never, ever, ever be larger than the number you're dividing by, the number out here on the side. Okay, so let me erase so I have some room again. What do we do with our remainder? It becomes the hat of the fraction, 12 over, and what number do you write on bottom? 28. It's the number that you're dividing by. That's the one that goes on the bottom. The number you divide by becomes the denominator. Divide the denominator. Okay, just trying to help you think of a way to remember this. Alright, so we have 2 and 12 28ths. 12 and 28 are pretty big numbers. My guess is it can be reduced. So let's go ahead and find the factor pairs to see what it can reduce to. Alright, so I had to erase to give myself some room here. So we're looking at the numbers 12 and 28 and seeing what it can reduce to. 12 divided by 1 is 12. 12 divided by 2 is 6. 12 divided by 3 is 4. And there's no numbers between 3 and 4, so that's how I know I'm done. I'll stop dividing. 28 can be divided by 1. It's 28. 28 can be divided by 2. That's 14. 28 can it be divisible by 3? Remember our divisibility rule? If you add up the digits, 2 plus 8 equals 10. Can 10 be divided by 3? No. So 3 doesn't work. How about 4? 28 divided by 4 is 7. Is that right? Yeah, 7. 28 divided by 5, that doesn't work because it doesn't end in 0 or 5. How about 6? 6 go into 28? It can't because it can't divide by 3. Remember, a number has to be both divisible by 2 and by 3 so that you can divide it by 6. So the next number after 6 is 7, and that's a number we already have over here to the side. Sorry, my pen's not working. There we go. Nope, still not working. Let me try again. 4 and 7, the only numbers are 5 and 6, so the following number is 7. That means it. That's all our factor pairs. Alright, look for your greatest common factor. It appears to be 4. And look at the numbers right beside it. That'll tell you what it reduces to, 3 over 7. So our final answer is 2 and 3/7. How'd you do? I know this right here is going to probably take some of you a lot of practice, and a lot of it has to do how well you know your division facts. Hopefully by practicing your division facts on a daily basis with the fast math will help you get better at reducing those fractions and changing those improper fractions to mixed numbers. Alright, I have several questions here just to check your understanding of today's lesson. First question. What is the correct way to write 36 in fraction form? Take a look at that. So how do we change a whole number into a fraction? Remember, you simply have to put a 1 under it. So it's this one right here, 36 over 1. Question 2. Which of the following fractions is equal to 1? Remember, any fraction where the numerator and the denominator are the same will always equal to 1. So it's this one right here. Which of the following is an improper fraction? Remember, a proper fraction is when the numerator is smaller than the denominator. It's not top-heavy. So it's that one right there. Which of the following is an improper fraction? Improper means top-heavy. So here we go. That's an improper fraction. Which of the following is a mixed number? Remember, a mixed number has a whole number with a fraction with it. Number 6, which of the following cannot be converted to a mixed number? Well, what's the only type of fraction you cannot make into a mixed number? How about proper fractions? So which one of those is a proper fraction? This one right here, because the top number is smaller than the bottom number, or the numerator is less than the denominator. And the final question, it says, describe the conditions in which a fraction can be converted or equal to a whole number, and create your own examples. Now, I didn't explicitly show you or tell you what this is in this lesson, but let's think about it. So this is going to be a challenging question for some of you. Well, one of the things that I pointed out before is that whenever you have a fraction whose numerator and denominator are the same, it's equal to 1, which is a whole number. I also showed you how if you had a number and you put a 1 under it, that's equal to its original whole number. Any number over 1 is always equal to a whole number. But also think about when you were doing your mixed numbers, taking those improper fractions, turning them into a mixed number. Let's say you had 24 over 2. If you take 24 and you divide it by 2, you get 12, and there's no remainder. Well, if there's no remainder, then it can't be a mixed number, can it? Because there's no fraction part to it. So that is just a whole number. So how do we describe this? 12 over 12, 36 over 1, 24 over 2. What is the conditions in which to make a whole number? Well, how about this? If the numerator can be divided by the denominator without any remainders, then it is a whole number, or can be converted to a whole number. Alright, so how do we write that? What did I just say? Okay, so here I wrote it out again for you. If a fraction's numerator can be divided by its denominator without a remainder, then it can be converted to a whole number. And you can make your own examples, but I would at least make 3 of them. Make one example where the numerator is the same as the denominator. Doesn't matter which numbers you choose. That equals a whole number. Write a number down and put a 1 under it. And show that that is also equal to a whole number. And then choose any number that you know that you can show that divides evenly by another number. Let me see. I always think even numbers are the easiest to do. So you write down any even number. You know that any even number can be divided by 2 evenly. So what's 18 divided by 2? It's 9. And there's no fractional part, no remainder. So it equals 9. So there's 3 examples of fractions that are also equal to whole numbers. Alright, go ahead and go to your practice and then do your quiz. Good luck with these.